Welcome to mobile computing tutorial. In this video, we will study mobility management in mobile computing or GSM. Using mobility management, one can make outgoing calls and receive incoming calls while in motion. In a wireless or mobile environment, the point of attachment constantly changes. The device moves from one location to another location, making all the routing table invalid. Therefore, establishing and maintaining a connection is complex. For mobility management, the techniques used are paging, location update, and handover. So, first one is paging. Paging is a procedure in GSM network to find out a subscriber's location before actual call establishment. In other words, paging is the procedure used for identifying the current cell location of an MS. MS means mobile station in order to route an incoming call. Using the BSS signaling channel, the paging message for MS is sent. That includes the IMSI as the identifier of the MS. So here you can see the figure of paging. So this is the paging mechanism. A page request message that contains the IMSI number of the MS is sent from the network to the MS. In response to this message, the MS will send a page response message from the MS to the IMSI. So this is the paging mechanism used in GSM. So here the paging starts at the location where the MS was present last. The paging starts at the location where the MS was present last. The location of the MS is recorded in the HLR and updated through location update. The MS is searched in these cells where it has the highest probability of being present. There are various algorithms for paging so that the MS can be located quickly with minimum effort and cost. So next one is location update. Location update enables the network to know the current location of a powered on MS. The location update enables the network to know the current location of a powered on MS so that the mobile terminated call routing can be completed. If the location of the MS is not known, tracking the MS through paging. To optimize this, location information is regularly updated within the core network. Through location update, the presence and location information is kept up to date within the VLR and HLR. When an MS is powered off, the HLR is updated within an explicit IMSI detach. So when the MS is powered off, the HLR is updated with an explicit IMSI detach. It is equivalent to HLR data for the particular IMSI being unavailable. In this case, the MS is not available and a connection cannot be established. So if there is an IMSI detach occur, the MS is not available and a connection cannot be established. In some cases, MS may be powered on but not be successfully connected to the network. For example, if the MS is in an out of coverage area. This is the case of an implicit IMSI detach. The location update can be done in the following conditions. When there is a mobile originated outgoing call, the location information is updated in the VLR and the HLR. Then next point is when the MS moves from one location area to another location area, the location information in the VLR and the HLR is updated. Then next condition is the MS updates the location coordinates when its location is more than k cells away in distance from the location information of the last update. So k stands for cluster. So if the ms moves from one cluster to another, the location update will occur. The ms updates the location information when it crosses exactly k cell boundaries irrespective of the distance. Then also, in addition, there is an explicit periodic location update by the ms. This time period is defined by the GSM network operator. Maybe the time will be 6 minutes to 24 hours. So next one is handover. In a cellular network, during a call, the user may move away from one tower, causing the signal strength to reduce and break. Therefore, the user needs to be moved to another cell where the signal strength is higher. This will result in changing the association of resources to another channel within the same cell or a different cell altogether. This procedure of changing the resources is called handover. The handover needs to be very fast without any disruption of the service. The handover can be initiated by the MS or the network. So the handover can be initiated by the MS or the network. There are 4 different types of handover in the GSM system, which involve transferring a call between channels or time slots in the same cell. So handover will maybe occur between channels in the same cell or cells under the control of the same base station controller. So there is another possibility of handover that will occur between cells. That means between BTS under the control of the same BSC. Then the next case is the handover between the cells under the control of different BSCs but belonging to the same MSC. Then another condition is handover between the cells under the control of different MSCs. The first 2 types of handover is called internal handovers that involves only one base station controller. Then there is another type of handover is called external handover. The last 2 type of handover is called external handover and are handled by the MSC. The first 2 type of handover is called internal handover that involves one BSC. This figure illustrates the handover procedure in GSM. In this figure we can see the mobile station, the serving BSS, that is BSS A and MSC, and the new BSS B. Here the mobile station wants to switch from BSS A to BSS B. This is called handover. So in this situation, the mobile station is currently under the BSS A. So the mobile station wants to switch from BSS A to BSS B. So the first message is the handover required message. So the handover required message is sent from the currently serving BSS, that is BSS A, to the MSC. So the MSC will send a handover request message to the new BSS, that is BSS B. In response to this, the new BSS B will acknowledge some messages like a handover request, handover command, and RIHO command. The currently serving BSS sends a handover required message to the MSC. The MSC sends a handover request message to the new BSS from which it requires radio resources. This message contains details of the resource that is required. The message may also specify the channel in use. On receipt of this message, the new BSS shall choose a suitable idle radio resource. This information is passed by the new BSS to the MS through MSC and old BSS using handover request acknowledgement, handover command, and radio interface handover command respectively. So these messages are the acknowledgement message from the new BSS to the mobile station, and also these messages contains a reference number. Reference number means handover reference number. The MS, that means the mobile station, changes its association from the old BSS to the new BSS with a handover access burst. So in this figure you can see the handover access based signal, that is signal number 6, that contains the received handover reference number. So this RIHO access message contains a reference number. The new BSS checks the handover reference number to ensure that it is the same as expected and that there is a high probability that the correct MS has been captured. When the MS is successfully in communication with the network, that is the radio resource message handover complete has been received from the MS, then the new BSS will immediately send a BSS MAP message, that is the handover complete message to the MSC and terminate the procedure. So after successful handover, a handover complete message from the BSSB to MSC will be sent. The MSC in this case will terminate the procedure with the old BSS by sending a clear command. So in this figure we can see the clear command message number 10 with cause handover successful. So after receiving the clear command from the MSC to the BSSA will send a message in response to this by clear complete message. So this is the handover procedure used in GSM. The next point in mobility management is roaming. So we have studied the handover mechanism in the previous topic. Handover relates to moving from one point of attachment to another point of attachment within the same network operation or same network operator. When this movement happens between two different networks, it is called roaming. Roaming allows users to seamlessly move around nationally and internationally and remain connected. When there is an call for a subscriber, the mobile phone needs to be located. A channel needs to be allocated and the call is connected. So this is a call connecting procedure. I repeat, when there is an incoming call for a subscriber, the mobile phone needs to be located. A channel means a transmission channel needs to be allocated and the call is connected. A powered on mobile is informed of an incoming call by a paging message sent over the paging channel of the cells within the current location area. The location update procedures and subsequent call routing use the MSC and both HLR and the VLR. The information is sent to the HLR is normally the SS7 address of the new VLR. If the subscriber is entitled to the service, the HLR sends a subset of the subscriber information needed for call control to the new MSC or VLR and sends a message to the old MSC VLR to cancel the old registration. An incoming mobile terminating call is directed to the gateway MSC or GMSC function. The GMSC is basically a switch which is able to interrogate the subscriber's HLR to obtain routing information and thus contains a table linking MS-ISDN to their corresponding HLR. A GMSE handles one specific PLMN. The routing information that is returned to the GMSE is the mobile station roaming number. It is called MSRN, mobile station roaming number. The MSRN is a temporary location dependent MS-ISDN number. So the MSRN is a temporary MS-ISDN number. It is assigned by the serving VLR for each MS in its area. MSRNs are numbers reserved by PLMN only for roaming use, and it is not visible to the subscribers. Roaming is of two types. First one is horizontal roaming and the second one is vertical roaming. So horizontal roaming is between two networks from same family. Horizontal roaming is between two networks from same family. For example, the GSM to GSM roaming or GSM to UMTS roaming will be considered horizontal roaming. The next one is vertical roaming. Vertical roaming is between two networks from different families. For example, GSM to CDMA roaming is an example of vertical roaming, or GPRS to Wi-Fi will be considered vertical roaming. When vertical roaming happens without any disruption of session of service, it is called seamless roaming. That is the end of this topic. Thank you.